If you haven't felt this way yet, confused about why your code does or doesn't work, you probably will at some point in the course. It's all part of the learning process. The main topic for this session is the if statement. I hope to keep the remaining videos shorter and more focused on a specific topic. After I explain a new part of Python, I'll give you an assignment that will allow you to code solutions to practice that skill, since writing programs is how you learn to program. There will be video solutions for each of the assignments, but try to solve the problems yourself before watching the answer video. Before I get to the if statement, I want to show you something interesting that Python does. One of the skills that you need to acquire is to become sort of a human computer. It's called tracing, and what you want to be able to do is go line by line through your own program as if you're the program executing those lines. So you should be able to tell what will be stored in each variable. If there are mathematical operations, you need to be able to calculate those and determine the result to find out what the final output of the program would be. I'll run this program. How many dimes do you have? Let's say that I enter 10 here. I have 10 dimes, and what I'm trying to do is calculate how many cents that would be. There's 10 cents in a dime, so if I have 10 dimes, I should have 10 times 10, or 100 cents. And let's see what the program comes up with. That's not 100. Do you have any idea what Python is doing there? In the last session, I stressed that the input statement always returns a string. The value that I typed in, 1 and 0, is stored as text in the variable dimes. And I don't change that at any place in this program. So down here, dimes is a string variable. In some languages, you would get an error if you tried to multiply a string or text by an integer, which is what I'm doing here. Python actually allows you to do that. It doesn't complain, doesn't give you an error message. But what it's going to do is create another string that is 10 copies of whatever was in this variable. So I typed in the number 10, it's just repeating that 10 times. And that is what is stored in cents. If we used a type to print out the type of this variable, it would be a string. That type of thing was a common problem with students in my previous programming classes. Now, here is a solution. Input will return a string, so we have to convert that to an integer. Here I'm doing that. I'm saying take whatever number was stored in dimes as a text value and convert it to an integer with the int function. And then that integer value gets multiplied by 10. I'll just run this first part and show you. So again, I'll type in the number 10. I have 10 dimes. And it correctly calculates the value 100 cents. And notice this comment that I have here. Using int in this way does not change the type of the variable dimes. This variable becomes an integer. Because int returns an integer value, we have to store that back in another variable in order for the change to occur. But we can just use this temporarily. So when I say int dimes, it's converting that to an integer just to use in that calculation where I'm multiplying by 10, but it's not changing the type of the variable dimes. That will make more sense as we go through more examples and you see it work more. Here's another variation on that. What I've done here is actually take int and wrap that around the entire input statement. So my left parentheses for int is there. My right parentheses to close the int is all the way at the end. So whatever is entered with the input statement is passed to the int function, and it's converted to an int, and then it's stored in dimes. So in this variation of the program, dimes is an integer variable at this point right here because it's getting the value from this function. Let's say I only have 5 dimes this time. It correctly says that I have 50 cents. Both of these programs have a problem in that if I enter anything besides a number, if I enter a letter, it's going to crash the program out. I can run it again. Let's just say I put some letters in there. Then I get an error and the program crashes. Not something that you want to happen. I'm not too concerned about that right now. Later in the course, I'll show you how to check and validate that you actually have a number before you use the int function on that. If statements are called conditional statements. You may write them slightly differently, but every computer language that I'm aware of has an if statement. To this point, we've been very limited in what we can do in a program, but the if statement is one of the first tools that will give us a lot more power in what we can create. An if statement always has to have a condition, a comparison that evaluates to yes or no, or in computer terms, true or false. For example, if I had a program that asked the user who is the smartest person in the world, and I'm asking them to enter the first name, and that name is stored in the variable person, this is my comparison statement right here, and this will have a yes or a true answer or a no or a false. If the answer they enter equals Vicky, that means this evaluates to true. Then I go this direction and I print a correct message. If the answer does not equal Vicky, this is not a true statement. I go to the false part, which is called the else part of the if, and I print an incorrect message. Most of the time you have both parts. You have something that you do if it's true and something that you do if it's false, although this part is optional. You could just do something if it's true and go on to the next part of your program if it's false. Now let's see how you actually write that in Python code. First, I have my input statement asking them to enter the first name of the smartest person in the world. To write an if statement, you just use if, lowercase, and notice how the Wing editor is color coding that. Person is the name of the variable that has stored the user's input. This is important here. I want to see if what's in person equals the text Vicky. But rather than using a single equal sign, I have to use two equal signs. Just put them right together. You don't put a space or anything between them. In Python, a single equal sign is assignment. Assigning something, placing something in a variable. The two equal signs is a comparison to see if two things are equal to each other. This is the true part. If this statement evaluates to true, these two lines will be executed. If this statement evaluates to false, that's what the else part of the if statement is for. If this statement is false, then only this line will be executed. And regardless of whether this is true or false, this line will be executed in either case. After your conditional statement, you have to put a colon. That's two dots. Should be the key to the right of your L key on the keyboard. You have to hold the shift down and press that to get a colon. This is called a code block. Python always requires the colon before a code block begins. And code blocks are always indented. You want to press the tab key to indent. Don't press your spaces. And actually Python, when you press enter after a colon, it will automatically indent for you. That's to keep you from making indenting errors. Python is the only language I'm aware of that uses indenting to mark code blocks. The else has to go back a level, back to the same level as the if, and then a colon after the else, and then again when you press enter after an else, it's going to automatically indent for you. To end your code blocks, to end the entire if statement, you have to go back to the previous level. That's why my print there on line 10 is all the way back to the left. Let's run this. I typed in Vicky, it compared that to this value, which they are equal, so it executed these two print statements. You can have one line in a code block or multiple, 2, 3, 4, 100, it doesn't matter. as long as they're all indented to the same level. Can you think of any problems with this program other than the fact that I'm probably really not the smartest person in the world? Do you see anything wrong with how it's working? I'll run the program again, and this time let's say I typed my name in lowercase. Now it's telling me that I'm wrong. It's comparing that lowercase v to the capital V, and the computer is very particular. It doesn't consider a lowercase v the same as an uppercase V. This part evaluates to false, which means it's going to skip these lines and come down here and execute that line. It's what we see right here. And then, as I said before, in either case it's going to continue executing at line 10. And here's a slight improvement on the code. Here I am saying if person.lower, and then the parentheses, equal, lowercase letters Vicky. What that is going to do is temporarily, for the purpose of this comparison, it's going to take whatever I type and make it all lowercase letters. So notice, to get out of this if statement, I have to back up on line 23 there. I'll just print out the value of that variable so that you can see that this does not actually change what's in person. It's only returning the lowercase version for the duration of this comparison. I'll just type it in all capital letters, and without that lower, it would tell me that I'm wrong. But now it says I'm correct. It took this as all lowercase, compared it to the lowercase version here, and saw that they were the same, so it printed out the true part of the if statement. Then when I print the variable person, you see it's unchanged. It's still exactly as I typed it in. To make that all lowercase, I would have to store that back into the variable, like person equals person.lower. There's also an equivalent upper. And because these have parentheses, they look like functions like int or print. They're actually called methods because they're in objects, but we'll get to that later on in the course. Let's take a look at one more example. I'm looking at the price of a computer, and I say here, assume there are no taxes. We're not really getting into anything like that yet. Let me just run this first. I only have $500. How much does that computer cost? So let's say it costs $505. The program prints out, sorry, I do not have that much money, will you sell it for less? Rather than an equals comparison here, I'm using a less than or equal to. If the price that was entered, 505, is less than or equal to 500, I print this message. Obviously 505 is greater than that, so it's going to do the else part. Notice that to do this comparison, once again, this is why I went over the string functions and int functions so much in the earlier sessions. Since this is stored as a string, we can't compare the string price to an integer price unless we do this conversion. Now this actually is changing the data type of price. I'm saying take the integer value of this text and store it back in price and make this variable an integer. So now I can do this comparison because these are both integer values. We could reverse the logic and make the comparison the opposite way to see if the price is too high. And here's the code to do that. Now, rather than changing price itself, I'm just putting the int in the comparison. Either way, depending on what you're trying to do with the program, either way works. But now I'm seeing if the price is higher than 500, greater than. Now I put the can't buy it messages in the true part. If this were false, the price wasn't greater than 500, then I would be able to buy it. Let's say the computer is 450. I get that else part. These are the operators that you can use for your comparisons. They're called relational operators, comparing one item to another. We'll use those in if statements, We'll see them again when we start looking at while loops. So remember, a single equal sign is always the assignment operator, assigning a value to a variable. Double equal sign is used to compare two values. The exclamation point with an equal sign means not equal to. X is not equal to Y. X is greater than Y. X is less than Y. X is greater than or equal to Y. Or X is less than or equal to Y. Here's a summary of the concepts covered in this session. These are the things that you should be familiar with. And here is your assignment. I'll cover if statements in, I believe, 2 more sessions. This isn't everything to know about ifs, but it's a good start. And what I want you to do is practice these 4 problems. And that will give you a lot of practice with actually writing an if statement, doing the indenting, and you'll probably forget to put the colon in there occasionally and get your error message. If Wing does not indent when you press enter, you know that you forgot to put the colon in. If there's a colon there and you press enter, Wing should indent your code automatically for you. Try to solve each of those 4 and the answers will be in the answers video. And as I say down here, you can make up your own true and false messages as appropriate. And if these are easy for you, come up with some of your own problems to practice even more. In the next session, we'll use if statements only with multiple conditions, using an if with and or to compare more than one thing at a time.